Okay, so uses of radiation. First of all, before we start, you have a quiz with true-false questions about uses of radiation to have a go at before we start, before you look at this PowerPoint. So make sure you've done that to see how much you already know. So then once you've done the quiz, for example, couple of examples of uses of radiation that we have. Smoke alarms, which detect smoke particles in the air. If we wait until a fire gets hot and use a detector that detects a heat, then it's often too late to help a lot with the fire. So we have smoke detectors that use alpha radiation to detect smoke particles before the fire has really got going. So alpha particles, they can penetrate, we know they can penetrate just a couple of centimeters of air, and what they do is they collide with air particles, knock electrons off those air particles and ionize those air particles. So they knock off electrons and the air particles become ions. Okay, so then when these air particles here have been ionized, the electrons that have been knocked off are then attracted to the top plate here, which is attached to the positive terminal of a battery. The positive ions, the atoms that have had electrons knocked off so that then their charge is positive, they are attracted to the bottom plate here, which is attached to the negative terminal of the battery. So under normal circumstances, an ammeter here would detect a tiny amount of current flowing between the plates, and that current is passed on by the ionized atoms or the electrons in the air that carry the current across this airspace. But if we have smoke particles in the way, the alpha particles collide with the smoke particles, which are much more difficult to ionize, and also they tend to pick up the electrons and the ions react with them, so that they're not free to move between the two plates. So the amount of current passing between the two plates is reduced when you get smoke particles blocking and absorbing in this space. So less current flows, and when the sensitive ammeter that's in the circuit detects this drop in current, turns the alarm on. We use beta radiation to control the thickness of paper in paper mills where we're making sheets of paper. So the idea is that the paper is very, very thin. Well, beta radiation will pass through paper, but some of it will be absorbed. So if we don't have any paper between the beta source here and the detector, we get a high count rate. When the paper comes through, that paper will absorb some of the beta radiation and we'll get a certain reading on a certain count rate on the detector here. If the paper is too thick, then the count rate will decrease, and that can then send a message to the control unit to tell the rollers to press harder. And the rollers there, they move closer together. They push closer together to make the paper thinner again. There's my mouse there. If the paper gets too thin, then the count rate at the detector will increase too high, and a message can be sent to the rollers to reduce the pressure there. And that keeps plastics, also sheets, paper, very thin steel. The thickness can be controlled in the factory using this method of a beta source and a detector. We can do things like find leaks in underground pipes without having to dig up the pipe. For example, we put in the water a radioactive isotope that is giving out gamma radiation or beta. If it's underground, we'd use maybe gamma, but if it's water that could get to close to the surface, we could use beta. So in the water we have an isotope giving out beta particles in this example, Okay, where we have a break in the pipeline and the water's coming out, we will detect beta radiation, but where the pipe is intact and the water isn't coming out, then the pipe will be blocking all the beta radiation and we won't detect any from the pipe. So we'll just walk along with the Geiger-Müller tube, and where we get readings there on the detector is where we've got the leak. So we dig up the pipe there and we can fix the leak. Okay, we need to use isotopes in these examples that have a short half-life. So after a short amount of time they stop emitting, or they emit, the count rate drops to very low levels after a short time. If we use isotopes that have a very long half-life, then they could be in an environment emitting radiation for a long time and cause problems. We could use gamma rays to check thick pipelines for like oil, and check the quality of the welding in the joins on the pipe, because in these cases we don't want to find out that the oil pipe's leaking when we put it in the sea. So we need to check that they're very well welded and very well connected before we put them in the sea and put oil inside them. So using a gamma isotope, a gamma emitter, we can check how much of that gamma radiation is being absorbed by the steel pipe, by the weld. Here, for example, if there's any cracks in the weld, then we'll get more gamma radiation being passing through that weld where there's a crack in the weld. And here, for example, we can use things like detectors like photographic paper. We put the paper around the pipe, photographic film, put the gamma source next to one side of the pipe, and we can like take a photograph of the thickness of the pipe. Where more gamma radiation passes through, where we have a flaw, then the photographic paper will change colour more, like an X-ray of the pipe. We can also use gamma radiation to kill bacteria, mould and insects in food, and because gamma radiation will penetrate like tin and aluminium, we can put the food into cans, seal it into a can, and then expose it to gamma radiation enough to kill any living things in the food, and that will pass through the metal of the can, so we can actually sterilise food that's inside tin cans. And also for medical equipment, especially plastic medical equipment like syringes that will be damaged if we heat them up, we can use the gamma radiation to kill any living organisms, any pathogens that are in that plastic or on the surfaces inside this packaging. The packaging then keeps it sterile and clean until we open the packaging and use it. We can use this on metal instruments as well, but another option we have for metal instruments is heating up to sterilise them, which is a bit cheaper, quicker and easier. But plastic we couldn't heat up because it would get damaged and melt. Okay, so now you have another quick quiz after this PowerPoint about the uses of radiation to fill in a table, and then we'll move on to more radiation stuff.